the CI/CD process more reasonable and more pleasant to people. So they can concentrate on, they can focus on writing code, writing applications, and not on deploying it or integrating with other teams. As I said, we're a team of engineers, and we work mainly with the Node.js stack. We do some JVM here and there, but mainly with the Node.js stack. And we use Node for the backend and React for the front end, and we use TypeScript because we like types. So today's agenda, we actually have 3 chapters here. In the first, we're going to discuss the challenge, or namely, what it's like, what it entails to make technical decisions in a company like Wix, which is not a small company. And so it's a little bit more complicated than just calling down the whole. Second chapter, we're going to go over the tool, our tool, the tool that we here. Okay, then. Just. Can you hear me? Okay. Okay, great. So second chapter, we're going to go over the tool, the SaaS that we build in order to take care of this mission, of this task. And final chapter, we're going to go over our first quote-unquote battle, or namely, Ken.
מה זה technical decisions? למה אתה קורא technical decisions?
We go over it in a minute. There's actually a slide about it, so it's very nice with art and everything. So the final chapter is how our first battle, how we closed a 0-day vulnerability in record time. So the challenge itself. One day our team was tasked with an important mission. We need to create a tool that will enable Wix to make technical decisions. And here you come and you ask me, what does it mean? What does it actually mean to make technical decisions? So making technical decisions, you know, as developers, we live in a very dynamic world, especially as JavaScript developers, we live in a very dynamic world. Every other day, there's a new framework, library, you name it, and you have to keep up with the times. So as developers, we oftentimes experience things like migrations, like integrations, like deprecations, because our code is a living thing and we have to maintain it and evolve it as time goes on. Some examples for technical decisions that we have to make. Let's say that we have to keep versions up to date, like use update to React 18. It's going to be a recurring example here. Deprecate old code. Let's stop using Angular. We asked before about old applications. This is here. Let's stop using Angular. This is another thing that we want to do. Maintenance. Let's make sure that our bundles weigh less than a specific threshold, so they load faster. And we can later on use dynamic imports, but the bundle should be smaller. Or even security. You might be surprised to find out that sometimes we make mistakes, and these mistakes involve saving our username and password inside the code. So there's one more thing that we want to make sure that we don't have security problems with our code. The next question would be, how hard can it actually get? I mean, as we said before, if you want to do something, you want to use React 18, if you want to stop using Angular, you can just, do that. And actually, when there's just one team, it's really straightforward. This really isn't a problem. You just go to your team and you tell them, guys, let's move to React 18. It has concurrent mode. We must use it. They're going to say things like, wow, boss, amazing idea. Everyone except for Bill. Bill had his own ideas. He's a smart mouth, and you can just ignore him and move along. What happens when there are 4 teams? When there are 4 teams, you still don't have to make a big deal out of this, right? Because these are usually people that you know and you work together over time. So you usually only have to write an email, right? Let's move to React 18. You can set up a meeting with the other managers and decide how and when you're going to do that, and plan a strategy, or you can send out the memo. This is a less efficient way, in my opinion, but I don't judge. But what happens when there are 400 teams.
יש בלאגן.
בדיוק, big balagan. How do we enforce standards at scale? How can we carry technical tests at scale? This leads us to chapter 2, the tool that we created in order to take care of this balagan. So, as we said before, we are a team of engineers and we're tasked with solving a problem. So we do what every good engineer does, and we look what other people did before us, right? We look for inspiration. And we try to think if we're familiar with a tool that is used to enforce standards on a smaller scale, right? A tool that you can use, a tool that you use on your daily life. I think that most of us here use it, and we use it to enforce standards, but in a smaller scale. And we found such a tool. We call it ESLint, and everybody here is probably familiar with it. Basically, every day you probably get hit by it. You write a wrong line or something. So we're not building a linter, but we did take our inspiration from the linter model, which means that we have a core engine. In our case, it was ESLint, and we have a set of rules. And the people who write the rules, the engine provides an API to write the rules, and the people who write the rules are people who want to actually help you to solve something. Let's say rules for React rules of hooks, right? Always tell me to put things in my dependencies array. Rules of TypeScript, and so on and so forth. So this is a model that we wanted to imitate, wanted to go by. And we created our own tool, and we called it with a beautiful name, CI Police. This is what we decided to call it. Yeah, that's why they call us, how they call us? Popo. It was Menayak, exactly. That's what the Hebrew people call us. People who speak Hebrew call us Menayak. So the CI Police model is similar, it's based on the model of a linter, but it's a little bit more complicated because we wanted it to work in scale. When you use ESLint, it's on your own project, but we want to be able to do this at larger scales. So our model actually contains 5 blocks. The first is the rules, right? We want everyone at Wix to be able to write a rule. We have the CI Police, the engine, the CLI that we wrote for that. And this runs inside the CI, hence the name CI Police. It runs in the CI in every build of every project at Wix. We run inside the CI as part of the CI pipeline, and we report everything back to a backend we call CI Police Station. From there, we can review the data that we collected, and we can actually be proactive and go and send notifications targeted at the code owners directly. Exactly to something. Okay. So we send targeted notifications over Slack. The CI part is pretty simple, right? Most CI pipelines, they go like this. You install, you build, you test, you deploy. In our case, we added a 5th step in the middle right there, CI Police. Basically, every build that is going on in Wix goes through us, and then we run the set of rules that we discussed before. We're going to see exactly what's a rule in our system. And if everything is okay, then you can move along. If there are issues, then we stop you right there. We tell you we have some issues, and you know we can help you fix them.
Why not for building and testing? Why?
That's a great question.
Why?
It's a great question. The first thing.
Can you repeat the question?
What?
Repeat the question.
Yeah. I'll just repeat the question. You're right. You asked why do we do this after testing and not before we even start? So the answer is that some of the rules actually depend on those steps, but some of the rules actually need the entire pipeline to run in order to understand things about your code. I'm going to say it in a second, but this is not code analysis. We're not doing code analysis. We're actually letting rule creators check anything they like. So some people, when we talked about production testing before in the previous talk, there are some rules that actually check that you actually run production tests. And in order for that to be feasible, you need to run the tests first. Okay, so this is CI part, and let's see what it looks like on an actual build. I picked a random repository right before we came here from Weak Stores. I see that they managed to merge the pull request. Good for them, it's a large pull request. So we can see that we have the build status here. This comes from our CI, not CI police per se. So we can go into the CI system. Let's view the full report. And we can see that we have one of the steps is Fed policy check. This is CI police. And we have a link over here. They can actually see a full report of what happened in that specific build for discount rules, PR, 1,937. So this is all the rules that we ran over. Ran over the build, so you can see everything here. You see that they pass everything, so that's very nice. That's probably why they managed to merge. And that's it. So that's what it looks like from the user standpoint. So in order to build the CLI, we again use the node runtime and we use it with TypeScript. We like TypeScript a lot. I don't think that I stretched it enough. And we use it, we built a CLI. So just to do some name dropping, we use Commander JS for the input. We use Chalk for the output because this runs inside the terminal, basically. And then we ran into a problem and we saw that if we publish it as an NPM package and we want to run it like with npx or something, we want to get it from there, it takes a long time to install. So instead, what we opted to do was to wrap it up using PKG. Using PKG, and essentially what we did, what PKG does is it takes everything together and wraps it with Node.js, batteries included, and then all we had to do was to publish the Linux binary. We publish it to our object storage, and all we do is download it. So instead of like 30 seconds, 40 seconds of install time, we have a second and a half of downloading it from the storage. So this is the engine. It comes to like this. And as we said, rules come from the outside. What we do is that every rule, each and every rule is an NPM package, and we deploy it to our internal registry. So if you guys are using npm.js, probably when you run an npm install, when you work on your own projects, we have a similar system, but it's internal. We run npm install, but it actually goes to our internal registry. So what we do, we deploy the rules into our internal registry, and we download it from them. And again, we don't install them. As we said, installing takes time. And we just untar them and run them and throw them inside a worker pool to run over the projects. So one last thing, how to write rules. So we created rule API for people to write. Essentially, all they have to do is to implement a class that extends our rule base class. The input, as we said, we don't want to just run static code analysis, we run everything. So the input is just the directory where the project can be found. And you do you. You want to check the output, check the output. You want to check the input, check the input. The source code, I mean, you want to check configuration, you can do just that. This rule gives you a verdict, pass, error, warning, ignore. Where pass is everything is okay. Error means that you failed miserably. Warning means that there is a problem, but it's okay for now. Take care of it when you have some time. And ignore means that it's not relevant to you. Let's say you have a node project, so use React 18 is not relevant to you. You will be ignored by the rule. So live coding, let's write a rule together. As you can see, we have here, we had to create a very approachable tool set. So people all around the company, even those who are not familiar with the system, could use it. So basically, it's very similar to other things you might have seen. I just start my work by writing yarn create CI police rule. And then I name it, let's say use React 18. But is this rule fixable or not? Fixable rules can be fixed for you. For simplicity's sake, let's say no for now. We don't have time for that. As you want to install, this is yarn 3. So since I have everything in cache, it takes just a few seconds. And we're ready. Let's go. It created a directory for us. Use React 18. We can open VS Code here. We created the project. This project has a single source file, index.ts, and as you can see, it has the rule class here. And everything is typed using TypeScript. And we're going to do a very simple thing. We're just going to check if you have React in your dependencies, in your package.json, and then we're going to check the version. That's it. We're not going to do something too complicated. So first of all, let's get the package.json. So import path from path. I'm going to say package.json path.join. CWD, you see that it's the input parameter, package.json. Next thing we're going to do, we're going to read it. So we're going to use fs from the fs promises module, package.json text, package.json path, UTF-8, and of course, we're going to have to await it. And finally, we're going to parse package.json, JSON.parse, package.json text. First thing we're going to do, we're going to check if we actually have React in this project. Otherwise, it's not relevant. So you're going to run if package.json dot dependencies dot React, or if not, package.json dependencies React. Then we're going to return, and it's going to help me. Ignore, because we don't have React at all. So we don't have anything to enforce here. If we do have React, let's make sure that it's version 18. So we're going to say package.json.dependencies.react. Let's say starts with 18. And I know it's not a good check, but for our demo, it's good enough. We're going to return severity pass. And finally, if it's not version 18, we're going to return severity error, and we're going to say expected React 18 got package.json dependencies React. And that's all you have to do in order to write a rule. The next thing you want to do is test that it actually works as you expect it to. So let's make it not work as we expect it to. Let's say 17 instead of 18. And you see that we already have the test directory here. So you test rules by actually providing them with examples. So let's create 3 examples. One of them is an error. We're gonna, nope, that's not what I wanted to do. We're gonna call it a folder project with React 16. And we're going to say package.json. I'm just going to say dependencies, React, let's say 16. Next example would be ignore. It's a project without React in it. Let's open it. And I'm going to rename it project without React. And finally, a passing example project with React 18. The last thing to do would be to run yarn test. We have a toolkit as well, Cypolice toolkit. We'll run test, so we're going to run yarn test. It's going to run the test, and of course, hopefully, it will fail over the right things. And indeed, as you can see, it gave us an output that it was supposed to pass for React 18, but it didn't. This is because this is actually 17 here. We're going to change it to 18. We're going to run it. And that's it. In a few seconds, that's going to be it. And once the rule is done, what the developer can do is actually head over to, okay, come on, don't get in the way. I'm going to go here to our Cypolice station. I'm going to talk a little bit about it in a minute. I'm going to go to the developers tab. You're going to add the rule. I'm going to say use React 18. Here we're going to tell it that the general rule and the ownership tag, let's say Fed Infra. I think that we have, yes, and support channel. We created the channel for it, React Native migration. This is where people will go when they need help. Next, confirm and done. Once the rule is there, it already starts to check project. That's it, that's all you have to do. It starts checking projects, and we have Tableau for business information. We have Sentry for error monitoring and Grafana for performance. So this is how you write a rule in our system. Now you might ask yourself, how comes we don't have any rule every day and everybody's breaking? And this is because we have a system in place to make sure that rules won't affect people. They only affect people when they're ready. So when you create a new rule, it's in development mode. You can research, you can see exactly what it does in production on all 7,000 projects that we have. You can see it live. And once you decide it's ready, you can ask the guild, which is the governing body, professional body at Wix. You can ask the guild to schedule a deadline, and then it moves to production where it starts sending alerts to people. And finally, when the time is due, it starts also to break builds, which sucks, and we hope to never reach a place where we have to break builds. That's it. In order to complement the system, we have the station, whose main task is to collect and display data about everybody. And basically what we have is thousands of builds reporting hourly to our system, and then we have our UI that displays this information. I'm not going to go too much into details here. I'm just going to show you what it looks like. So basically, if you're a manager at Wix, what you do is you go to the rules tab in your CI policy station, and you can see every rule. So if we talked about Yoshi before, we have a rule that we want people to use Yoshi Flow VM. This is what we demonstrated in the previous talk. And as you can see, out of 200 projects, 163 are passing. They use Yoshi. 14 fail, and 28 are opted out. They had a good reason why not to move to Yoshi. Probably legacy project is going to be deprecated. So you can just visit the specific project. You can see it here, similar to what we've seen before. And finally, we have a Slack bot. We gave it the name Robocop because it's CI policy, so why not? So essentially, when you have a failing status, instead of just breaking your build, we send a notifications, and we usually do this before we start breaking builds, so you can actually know that you have something that you have to fix. We want to reach our developers and not have them chase us later on. So when they get this notification, they get a list of all the failing checks. This one failed a specification that asks people not to use asterisk when they write their package JSON, and not use latest, but use specific versions. And they can learn more, they can get support, they take into the support channel. And in some cases, this is one of them, they can actually fix their project. They click the button, and a few seconds later, they have a pull request ready in the repository with the project fixed. Not all rules can be fixed. Some rules might be too complicated to fix, but those who can, we require that people write fixes for them. So to sum it up, we cover every project at Wix, everyone can contribute rules, and we need to notify people when action is required. Finally, and this is the final chapter, we're talking for too long now, our first quote unquote battle, or how we use the system in order to mitigate an exploit in our system. A vulnerability, not an exploit, it was never used. So back in 2021, a security researcher called Alex Pearson, he published an article describing what he called a dependency confusion. He used it to hack into large-scale companies such as Microsoft, such as Apple, and basically the attack is very simple. Say that we have a package, let's call it Wix secret, and say that, like Wix, the company has a private registry. Under some circumstances, if I'm an attacker, I can publish Wix secrets to the public NPM, and somehow, under some circumstances, confuse NPM to install it from the public registry instead from the private one. Now, this is actually a very serious vulnerability because it allows for remote code execution. You can basically make code run on your laptops, on your servers, on everything. So obviously we had to fix it immediately. This was also to add to the pressure. This was also a 0 day, which means in computing 0 days means that this is an exploit that is already there. It's already out there. People can already exploit it. And if you don't deal with it now, you probably deal with it only after they will abuse it. So the solution, by the way, is very simple, also according to Alex. Name your packages in a way that others won't be able to impersonate to them. In our case, just add the Wix scope at the beginning. Since the Wix scope is also owned by Wix on the public registry, no one can actually imitate this name in the public registry. So very simple, very straightforward, but we have 4,000 projects to fix. Luckily, at that point, we already had an earlier version of stack police in place, so we were able to devise a plan to mitigate this risk. We first created a rule that checks whether a project uses the Wix scope or not. We then created a support channel where everyone can come together and ask questions and consult with each other for the best methods to take care of the problem. And we used the CI police station, all the data collection capabilities that we have, in order to track the progress in real time. And as for the results speak for themselves. So as we can see here, all the projects at Wix use an internal scope. No project is not using the scope, and this took us a little bit, the majority of the projects were covered in a little bit over 2 weeks, and that's it, in a company with 4,000 projects. As you can see, we have 7,000, almost 7,000 projects today. So as you can see, no project since has broken this rule. So it's not only, we not only use the system to fix a specific problem, but we also keep it that way for future generations. Okay. So what do we take from all this? First of all, when you want to write a system like this, adding rules should be easy, because innovation is continuous and we need to be able to make writing rules approachable so everyone can write them. Transparency is very important because when you have a large company such as Wix, you need to be able to track the progress of everybody at the same time. So we need transparency, both ways, by the way, both managers and developers. And finally, communication is everything. If you wait for people to come for you, they will probably get past the deadline and then they will come to you, but they will come angry. So you have to be proactive and you have to send targeted notifications at them in order to be able to communicate and start a discussion before it's too late. Master all three, and you can work in harmony even when you have thousands, hundreds of teams. That's it.